process and have more applications in qualitative and quantitative analysis in analytical chemistry. The coordination compound play a vital role in metallurgy as well as medicine. Such a wonderful and interesting subject. You play an important role in our human life also. So let me see the basic concept of coordination chemistry. I'm going to discuss about the terminology of coordination chemistry in this slide one by one. So here I've shown a few terms such as a coordinate central metal ion, coordination sphere, coordination number, and ligands. So what do you mean by central metal ions? So it is the central metal ions, so the species which accept the pair of electrons. It is known as the acceptor. This is usually is a metal ion. It is act as a acceptors. So it is a Lewis acid. So what is the second? The coordination sphere. So in this complex compound, the central metal atom and ligands attached to it. It is always is written in the square bracket. So this part is called as a coordination sphere. So the third one is a coordination number. So what do you mean by coordination number? The coordination numbers, the number of ligand attached with the central metal ion or number of donor group attached with the central metal ion. So that is called as a coordination number. So ligands, so already I told the ligands is a Lewis base. It's donate the pair of electron to central metal ion. So here I have shown the cobalt complex. The cobalt as act as a central metal ion. The amine, the ammonia is called as amine. The amine, it's six amines is coordinated with the cobalt, so the coordination number is a six. The ligand is amine. Okay, there's another one example I shown here. The coordination sphere is a cationic sphere. The whole the square brackets is contain positive characters. The ion Fe, its compound is act as a central metal ion. Yet here two type of ligands are presented in chloro and amine. So the six donor groups are presented in the square brackets is donated the pair of electron to central metal ion. So the coordination number is six, and the ionizable anion. So that is means it is a common sheeted ions are present in the outside the sphere. So it is a ionizable ion. Okay, the next slide. I hope the next slide you will discuss about the nomenclature. First of all, I hope to everyone to understood the basic concept of terminology. So what do you mean by central metal ion? So the what do you mean by coordination sphere, and followed by ligands, so everything. So now how to fix the name, how to write the name for the coordination compounds. The nomenclature of coordination has some rules. First you must be write a cations, you give a first preference, and then anions, then write anions. So for example, here having a two example. One is a anionic sphere, another one is a cationic sphere. The cations you write first. So the pentamine, the first example, the pentamine chloro cobalt 3. And next within the square bracket, so those metal ions or ligands in the contains in the within the square brackets, you write without space, pentamine chloro cobalt 3, and give a phase space, and then write an anion. So the next one example is the cation is a sodium. So you write first preference, give the for sodium as a cation, then give a space, then write here tetrachloro. So another ligand is a oxo. So tetrachloro oxo molybdate 4. So I give another rule for it. The nomenclature. The first ligand put in alphabetic order. First condition. The second, the prefix of ligands appear more than once or twice. You write a di, tetra, and dentra, penta like that. Name of metal. Suppose a metal presented in cationic sphere, you write as such, whatever. Maybe the cobalt is present in the cationic sphere, you write a cobalt like that. That same cobalt present in an anionic sphere, you must be write your metal prefix, you added 8. So cobaltate. Suppose the chromium present in cationic sphere, you write chromium, you write a chromium. Suppose chromium metal is present in anionic sphere, you write a chromate. So here I have given a aluminum aluminate, the chromium, chromate, cobaltate, copper, cuprate, and gold, aurate. Yeah, like that. I give a few example in here. Then after that, they write the metal. You add oxidation state in Roman numeral. Okay. For example, first example, the tetracyanonickelate, the true ion. Why you add a 8? The anionic sphere. So that's why indicate the metal present in within in the anionic sphere. So that's why you are added a 8. Second one is also the anionic sphere, the hexachlorocobaltate 3 ion. Okay, the third one is a cationic sphere. So that mean dichlorocobalt. You're right, like cobalt, and 3 ion. Here, the first three examples have ions, so no counter ions for it. So you must be right like the end with ion. Suppose the counter ion presented in that complex, you no need right like ion. A fourth example, dichloro bis ethylene diamine chromium 3 space sulfate. The sulfate is a counter ion for that complex because the coordination sphere have 2 minus, 2 plus, sorry, 2 plus. The 2 plus, so that